Talk about speed and velocity. As you see, we're going to start with speed first. And it's given the symbol v. Is a scalar, which means it has magnitude only. We find it using distance divided by time. Two examples of speed would be 8 meters per second and 19 kilometers per hour. Now, a quick calculating example. A sprinter runs 100 meters in 10 seconds. Find his speed, and his speed would be v equals s divided by t. v equals 100 meters divided by 10 seconds, giving a speed of 10 meters per second. We're going to talk about velocity, and as you see, it's given the symbol v with the arrow, indicating that it is a vector. And as a vector, it has magnitude and direction. We find velocity by dividing the displacement by the time. And two examples of velocity are 5 meters per second north, 30 kilometers per hour south. Now we're going to do a calculation example here. Plane flies 300 kilometers east for 2 hours. Find its velocity. So to do that, we're just simply going to use the velocity equation. Displacement divided by time is equal to 300 kilometers east divided by the time, which is 2 hours, giving us a velocity of 150 kilometers per hour east. We're going to talk about the average speed and velocity, and it's given the symbol v bar. And it is the total distance or displacement divided by the total time. So this takes into account any stops along the way. And as you see here is an example. A hiker walks 20 kilometers north in 2 hours, then rests for 30 minutes. He then hikes another 15 kilometers east in 1.5 hours. Find his speed and velocity. Well, we're going to start with a vector diagram. We have our direction indicator, scale, and we've drawn the vector diagram here. 20 kilometers north, vector A, 15 kilometers east, vector B, resultant from the tail of the first to the head of the last, vector C, and our reference angle for direction, theta. So we're going to go ahead and start out by finding our total time. T1 plus T2 plus T3. So our total time is 2 hours plus a half an hour for his rest plus 1.5 hours for the last leg of his hike. So we get a time of 4 hours total. Now notice, because we're talking about the average time or velocity, we use the total time including the rest time. Distance covered is just nothing more than S1 plus S2, the magnitudes of the two legs, 20 kilometers plus 15 kilometers, total of 35 kilometers. Our speed is nothing more than our distance divided by the time. And we get a speed of 8.8 kilometers per hour. Now notice that's not saying that every instant he is walking 8.8 kilometers per hour, because he does have a rest period in there. So for his displacement, or we're going to use the vector equation, C is equal to A plus B, all vectors. The magnitude of the displacement is going to be A squared plus B squared. That calculation is pretty simple. 20 kilometers squared plus 15 kilometers squared. Doing our arithmetic. we find the magnitude of the displacement is 25 kilometers. Now we need to find a reference angle, theta, or directional angle. Again, we're going to use the inverse tangent, which is nothing more than the opposite over the adjacent. (15 kilometers) divided by 20 kilometers, and gives us an angle, theta, of 36.9 degrees. This means our resultant vector C is 25 kilometers in magnitude at 36.9 degrees. Now this is straightforward and simple because north is 0, east is 90, and this is the true reading. Moving on to the next topic here, instantaneous speed and velocity. As you can see, it is the speed or velocity at a given instant in time, and this applies to bodies that are not moving at a constant rate. Quick example, ball rolls up a hill and slows at a rate of 0.5 centimeter per second. If it has an initial or starting velocity at t equals 0 of 4 centimeters per second, find its speed after 2 seconds. Well, I just made up a quick table here, and I would advise you to do the same thing. Take a quick look at that, and we just look up the speed or velocity at 2 seconds. We find that it's 3 centimeters per second. Alright, next we're going to talk about distance and displacement traveled at a constant speed or velocity. And distance is nothing more than speed times time, while displacement is velocity times time. Fast little example. The car is driven east at 90 kilometers per hour for 2 hours. Find its displacement. Displacement is velocity times time. Plugging in our values, the velocity is 90 kilometers per hour, and that is going east, and that's times 2 hours, giving us a displacement of 180 kilometers per hour east.